All right, we're going internal. We're going to have a short introduction, then we're going to type out all the code, and then I'm going to explain to you how it all works and why we coded it that way. What you're going to learn, you will learn how to start a DLL project, how to create a thread that's going to have your hack loop in it, how to get a module base address internally, how to attach a console for debug output, how to use a pointer to validate that the game is in a hackable state, therefore you're not dereferencing any null pointers, etc. Then we're going to show you how to typecast addresses to pointers so that you can change them because we don't need to use write process memory anymore. And going to show you, in the last tutorial we had a not function and a patch function external. We're going to show you internal variants of that. And like Cheat Engine has the freeze function, where you can freeze values, we're going to show you how to do that just by continuously writing to the same address in a loop. We're going to show you how to eject a DLL, and that will let you, you can eject your DLL while you're testing and debugging, recompile it, and re-inject it without having to restart the game process and having a file that's locked. So let's get started. You're going to want to open up Visual Studio, start a new project. We're going to call this first internal hack. We're just going to use the DLL template. Now, while that's starting, everyone knows we have the beginner's guide. It's step by step. So basically, you have to do all the videos before this one. So this video will be like number 11, and so you'll do everything before it. The last video preceding this one is our How to Hack Any Game Part 3, where I make a little bit of a fancier external trainer. And you're going to want to download this attachment. And once you get that attachment and you extract it, you're going to get this folder. You're going to get the cheat table that you're going to need to reference if you want to see how any of these things work. And what you're going to want to get is these mem and proc files right here, which we're going to grab and put into this project. So once the project's created, let's right click it, open folder in File Explorer. Let's go back to our previous folder and copy and paste those files. And then we're going to grab this folder. We're going to right click and add existing items. And we're going to add those mem and proc files. Let's add a few filters to be organized, right? Mem, proc. And I always like to put precompiled headers in there as well. And then go to DLL main. We're actually just going to delete that main file. We're just going to get rid of it. We're not even going to use it. So here's our DLL main function. And let's kind of stub out what we want to do here. So first thing is we're going to have a hack thread, a dword win API hack thread, and the parameters are going to be h module. And first thing we'll notice is we need to include windows.h. We need to include iostream and tool help snap. I think that's it. We're going to want to include mem.h, right? Proc.h, I don't think we're going to use it, but we're going to put it in there. Let's grab these two guys here and these two includes, and let's go to our standard header and let's paste them in there. And then let's go back here. So basically, we're going to stub out some things. We're going to create a console. We're going to get module base. We are going to do a hack loop. We are going to get key input, continuous write, /freeze, whatever you want to call it. Then at the bottom, we're going to clean up and eject, okay? So if you're not familiar with dynamic link libraries, you can I'll link these in the description or on the thread. Visual Studio, Microsoft, they have 2 tutorials on working with DLLs. Basically, dynamic link libraries were created because in the past, everything was statically linked. When you were making a binary, any library you had to be assembled and placed inside of your binary. It led to the disk having a bunch of redundant information because all files use the same libraries nowadays. So the dynamic link library allows it so it's one file on disk that can be used across many processes. So you can type in DLL main on MSDN and get a full breakdown of what it all means. Let's just open right here, case DLL process attached. That means basically that load library is being called. And we are going to do create thread, null pointer 0, LP thread start routine, hack thread, H module 0, null pointer. All right, and then we're going to take the whole thing and we're going to close handle around the result of it. All right, so when the DLL gets loaded, it's going to create this thread. So to create the console, we are going to do alloc console file pointer f FRE open underscore s address of f on out $, w std out. Then we're going to do a little test output here, stdc out. All right, and then we're going to do uint pointer underscore t module base equals get module handle L macro AC underscore client.exe. And then we are going to typecast the whole thing to a uint pointer underscore t. Then we're going to define some bools. Bool b health equals false, b ammo equals false, b recoil equals false. Then we're going to have our while loop, right? While true, if get a sync key state, bk underscore end, we're going to end the result with 1. And this is going to be our key input section. And our continuous write and freeze is also going to be in the while loop. And so basically, if we hit the end key, we're just going to break out of the process. We're going to do, I think, 3 more of these. And it's going to be vk underscore numpad1, vk underscore numpad2, and numpad3. All right. And we're not going to break on this one. We're going to, these are just going to be toggles. B health equals B health. That should be the opposite. Numpad 2 is going to be the ammo toggle. B ammo equals opposite of B ammo. Same thing here. B recoil equals not B recoil. But we're going to toggle in here, and we're also going to check if the B recoil is set to true. Then we are going to nop. Else, we are going to we're going to write back original instructions. All right, so now at this point we need to show how do we do that? How do we do it internally? So let's open mem.h. We've got our 2 patch functions here. One thing we're going to do is we're going to take this findDMA ADDI and we're going to put it into our memory header. Okay. And we're going to do the same thing in the source. Paste that in there. Now we're here. So basically, what else do we need to do? We need to number include vector. And basically what we're going to do is we're going to do these same 3 functions again, and we're just going to make internal versions of them. So it's actually pretty easy. We're just going to remove the EX, and we're going to move any reference to the process handle, right? Now we're going to go to the source file and we're going to do the same thing. Let's grab all three of them, paste them again, remove the EX, remove the handle to the process, remove the EX, handle to the process. And so now we have our three new internal functions, and let's see what they're going to be. All right, so for our internal patch function, base, it's pretty easy again. Virtual protect EX, we're just going to use regular virtual protect. We can get rid of the H process on both of these. And instead of write process memory, remove the handle, remove the null pointer, and just change this to memcopy. All right, for the internal NOP, we are going to, it's basically going to be the same thing as this. So let's copy this and paste it over it. And instead of memcopy, we're going to use memset. And source is just going to be defined as a literal 0x90 for the NOP function. And then for our internal find DMA addy, which just reads multi-level pointers for us, we can delete this read process memory. And we're just going to do address equals u int pointer underscore t address. So we're going to cast to a pointer. And we are going to then get the value of that. Okay, that's all you have to do. It's that easy. So now we need to go back to DLL main. And our NOP is right here is going to be mem NOP module base plus 0x63786 comma 10. And then this first argument we're going to typecast to a byte pointer. And then we're going to, I'm just going to grab this from my, basically in Cheat Engine, these are the instructions that we're going to overwrite. I'll show it to you later. And we're going to do mem patch, same thing, right here. And we're going to do byte pointer cast again. We're going to do slash x50 slash x8d slash x4c slash x24 slash x1c slash x51 slash x8b slash xce slash xff slash xd2. And that's 10 bytes again. Then we're going to have our continuous writes and freezes. We're going to do u int pointer underscore t pointer local player pointer equals module base plus 0x10f4f4. You guys should know all of these addresses and stuff from doing the previous tutorials and how to find them. It's really easy. If you don't know, go back and watch the previous videos. So we're going to get the address of the local player pointer, and then we're going to do our freezes. We're going to do a null pointer check right here, if local player pointer, and that way our hack only executes during when the game's actually in session, because like if you're in the menu or something, the that will be a null pointer. That won't work in all games, because some games will just point to uninitialized memory, but not as all cube. So if B health, we are going to do local player pointer plus 0xf8 equals 1337, right? We're actually gonna dereference the local player pointer, add F8 to it, and then we're going to cast the result to an int pointer, and then we're going to dereference it. If b ammo, we're going to do uint pointer underscore t ammo address equals mem find DMA addy module base plus 0x10f4f4. We're going to initialize the array of offsets 0x374, 0x14, 0x0, and then we're going to do int pointer ammo equals int pointer ammo address, basically dereferencing it to get a new pointer to the ammo. Right here equals 1337. So that's basically 3 lines breaking down each little like piece of that. But we can also just do it in 1 line of code here, and I'll show you that. Grab this whole thing, copy it, and paste it, and just say the value pointed by this address casted to an int pointer equals 1337. Now after, still inside of our while loop, we're going to sleep for 5 milliseconds so that we're a little bit efficient here. And then we're going to clean up and we're going to inject. So we're going to do fclose, f, free console, and then free library, and exit thread, h module 0, return 0. Now, if we did everything correctly, this should compile. Let's hit F7. It did not. What did we do wrong? Oh, I think mem.h, we need to include a vector, which we did. We have 2 of these. Find DMA. Find DMA. I'm not sure actually. Unresolved external. Great. Nice going, Rake. Oh, duh. Scope resolution. Mem, we got to get access to that namespace, right? Duh. Okay, so now I have 7. It compiled, thank God. So let's talk about what's going on here. And I think the best way to do this is just to debug this. So we are going to put a breakpoint on the create thread close handle call. We're going to breakpoint on the cleanup. We're going to breakpoint on each of these. On these 2 calls right here, and on the first one here. Now, right-click your project, click Properties, and go to Debugging. We want to set it so that debugs like as it attaches to a process. We're going to set the command to wherever assault cube is. Apply, we're good. Let's start assault cube. And let's attach to the process. Okay, notice the breakpoints are not being hit, and that's because we're not injected yet. So let's open up the GH injector. Let's add some files. Projects. First internal hack. Video. Oh. All right. And let's inject. All right, so first thing you notice is this injecting thing is stuck here, and that's because the DL injector hasn't detected that we've injected yet, because load library is basically DL main is not returning true. It's waiting for that. So here's what we'll do is we'll just let it go, and then we'll move forward, and then the injector detects that it's returned, and now everything's fine. And so that illustrates an important point here. So right here, you don't want to do like any sort of code here, okay? You don't want to do anything in here except create a thread. The reason for that is because it creates loader lock, which can mess up the operating system and other things. So you definitely don't want to do that. You just want to create a thread and then let this return. So we're going to call create thread. You can look that up on MSDN. Let's just peek the definition real quick. Security attributes are not a big deal. Stack size doesn't matter. What does matter is LP start address. That's going to be the address of the thread, and we are casting it to an LP thread start routine in order to make the compiler happy. If we peek that definition, it's just a pointer to a dword win API function pointer, okay? And so that's why you'll see when we define this, we define it as dword win API hack thread. And win API, all it is it's a standard call, right? But it does need, all those things do need to match up in order for it to work and compile. So the next thing here, H module, that's the LP parameter or LP param you might see. That's basically, think of it as like a command line argument for the for your DLL, right? If you need to pass anything to it, then that's how you do it. And in this case, we're going to pass the handle to the DLL itself, and so later that we can eject it using it. Creation flags doesn't matter for this use case, and neither does the thread ID. We pass in a pointer, not a null or a 0, because it's looking for a pointer. So let's just make sure our compiler's happy, right? All right, so basically DLL process attach is the only thing really important. Maybe process detach you might use occasionally, but honestly, this one's the only one I ever use. So let's go back up to where we were. So allocate console is going to create a console for us. We're going to create a file pointer. Doesn't matter what it is. It doesn't even need to really exist. And then we're going to open a file stream, and we're going to use the _s for the secure version. And con out is just like this. These both are just like the standard output. I think con out is like gets the current console output of the process and what type of output is using the standard one, and the W gives us write access to the file. That's what that does. Then we just do a little test output, so we can see we're attached and we have our output. So now you can do any sort of debug stuff you want in there, but honestly, you should be using the Visual Studio debugger for everything. It's so much easier and has such a better feature set. And who wants to type out all shit anyways? Anyways, we used to use get module base address. Was a function we used externally. When you're internal, all you have to do is call get module handle. How does the operating system keep track of handles to modules? Well, it just does it by the address. So when you call get module handle, the handle to the module is just going to be the address where the module is loaded at runtime, right? So that's what we do. We cast it to uint pointer and store it. Why do you use uint pointer t? It's because if you change your build type to 64-bit versus x86, it'll compile to the right size, and that way you don't run into trouble down the road. Basically want to make everything architecture agnostic so you don't run into any trouble. Define our bools here, right? Enter our while loop, which is gonna just loop and loop and loop for us. Now let's go into our game and let's try numpad 1, which is we're now in the freeze, right? That's where it broke. So basically we toggled on the health hack, and we're going to take the local player pointer. We're going to dereference it. So now it's pointing to the local player object. We're going to add offset F8. So now we have the address of the health. We're going to cast it to an int pointer, okay? And then we're going to dereference it. So the value of the health pointer is going to be assigned the value of 1337. You do not need to use write process memory to do this anymore. When you're internal, it's as simple as that. You have 100% access to the whole all of memory, and you can write your code as if you were like the original developer. So that's how you do it. Everything you're going to do, you're going to cast it to a pointer, and you're going to do the value of, and then assign it or read it, whatever you're going to do. So that's easy. Let's continue. We can see, or not. Right, so this is a freeze. So let's undo that breakpoint and go back. We can see that our health is set. 1337. And we haven't been harmed because our health is too high. Okay, so let's now try numpad 2. So our ammo hack is initiated here. So basically, there's kind of 3 different things we're doing. We were showing you how to nop and patch internally. We were showing you how to assign one address with one offset of value, and then we're going to show you a multi-level pointer version. So we're going to call find DMA addy, right? This is the local player pointer. And then these are offsets. We could even copy local player pointer in probably and paste it in here and it would work the same. So let's step into, actually I stepped over that. So just click continue. Now we're in it again and we're going to step into, and we can see in our address, right? We're going to slowly add an offset, dereference it, add an offset, dereference it. And we're going to keep doing that until we go to return, and you're going to see that it returns the address of our current weapon ammo. So we're going to take that address and we're going to cast it to an int pointer, right, and put it into our ammo pointer, and then we're going to dereference it and assign the value 1337, right? The value of the address pointed to by the ammo pointer is now 1337. So this is broken down into 3 lines, so it's kind of easier to understand, but you can do it just in one big line, just like that as well. All right, so next up, let's see our recoil. So hit numpad 3, and we're gonna nop here. Let's open Cheat Engine. And attach to the process, memory view. Let's do control G, right? And then we're gonna do AC client.exe plus 0x63786, and that's going to bring us to the address that we're going to nop, right? So we'll just have that off to the side there. When we step into this function, right, it's going to get us read, write, and execute permissions on that memory address. Same thing from our last video, right? And then we're going to call memset, right? Which is going to set the memory. Like memcopy, it's going to copy from a source buffer to the destination. In this case, it's just going to write every byte 0x90, right? So when we step over that, we can see everything gets knopped. And then we're going to restore the regular protections, and we're going to exit out. So let's hit continue again. And if we shoot our gun, we have no recoil, right? Now let's hit 3 again, and now we're going to disable the no recoil by writing back those bytes using the patch function. Step into it. Again, we're going to virtual protect so that we have the right permissions. We're going to memcopy from source to destination, and you can see now that all those instructions are back. We're going to restore our permissions and then continue. And now our recoil's back. So next thing we're going to show you is the cleanup and eject. Now sometimes when you're debugging, you're going to want to eject your hack, change your code, recompile it, and inject it, and you don't want to have to keep closing the game because you obviously can't write to it because the file is going to be locked. Cheat Engine will also lock the file sometimes, so we're going to close Cheat Engine so we don't run into that issue. And then let's hit end. So fclose is going to close the file. Free console is going to free the console, right? There's no more console. And then free library and exit thread. And we can step over. And now this is going to return. We're still attached though. If you hit stop, it's going to stop the whole process. What you want to do is go to detach all. Now we have no hacks, right? And everything's back to normal. Let's say we do int x equals 5, right? We're going to recompile with F7. And now let's inject again. And we're back. So I can do end, inject, end, inject, end. So that's really cool. So that's basically everything you need to know to get started with internal hack. With this as a base, you could add a bunch new features because basically all you do for like a basic internal trainer, you're knopping, you're patching, and you're writing and you're reading, right? So I don't think there's anything else for me to cover. I think that was pretty self-explanatory. Um, in the next video, we'll be doing something with reclass. So I hope you look forward to that. Peace out. If you'd like to support Rake's growing cocaine addiction, you can donate to me at guidedhacking.com/donate.